Hello everyone, this is Shahinur Rahman Daskar from the Department of Computer Science and Engineering, National Institute of Technology, Silchar, Assam, India. Today I am going to present EnAsCorp1.0 English-Assamese Corpus. So these are the outlines which I am going to cover. First I introduce, then about our paper, then corpus, then data extraction techniques, domain coverage, and then finally then baseline systems, then finally conclusion and future work. Corpus preparation is one of the major issue for the domain of machine translation, especially for low resource language scenario. Country like India, where multiple languages exist, machine translation attempts to minimize the communication gap among people with different linguistic backgrounds. Although Google covers many various languages all over the world, but it lacks in Assamese language. In this paper, we have developed EnAsCorp1.0 corpus of English-Assamese low resource pair, where parallel and monolingual data are collected from various online sources. Also, we have implemented baseline systems using statistical machine translation and neural machine translation approaches using the same corpus. Assamese, also known as Ahomia, is one of the predominant languages of the Indian state Assam. It is recognized by the Government of India as official languages. To facilitate greater access among local community, it is very much essential to translate the official documents written in English, like order, notice, message released by the Government of India, into the regional language of Assam. But due to the non-availability of suitable corpus, the MP system for this language pair still remains in the beginning stage. So this is one example of English-Assamese sentences, like he lives near the church. So here he the subject and lives is the verb, and church is the object. But in Assamese, the word order is changed, like subject, object, verb. তেখেত ঘৰ গীৰ্জা ঘৰৰ ওচৰত থাকে. So word order is completely different from English. Another difference from English is that it is the more inflected languages. This is one example where girja ghor, so girja ghor is the stem word and ro is that suffix marker. Parallel data is now coming to the corpus. Parallel data is important for the model to learn word alignment between source and target sentences by estimating parameters. So it is related to adequacy factor of a good translation, where main concern is the meaning of the target with respect to that source languages. And monolingual corpus is used to produce a fluent translation of the target language. So here the main concern is the fluency of the good translation. So these are the corpus statistics which we have collected from various sources like Bible, Hobdo, Crosby, Seva, Multilingual Question Paper, Learn Assamese, PM India. So these are the source, and the next column is after that is the number of sentences, and then tokens. And we have for monolingual corpus we have collected from various web pages, blogs, holy books like Bible, Quran, Gita, and we have collected that monolingual data of Assamese. And after collecting the sentences, then we have split the parallel sentences into train, validation and test data. So train data becomes 203315 sentences, and validation is 4500 sentences, and test comes 2500. So these are the example sentences from various sources. So first is Bible. In the beginning God created the heaven and the earth. Aditya Ishwar Akashmondol aru Prithivi Shristi Koribe. So this is one example from Bible. Then like this from Hobdo, there is another parallel sentences, and Also we have included monolingual sentences like ভারতীয় ক্রিকেট দলৰ প্ৰাক্তন বলাৰ সুনীল যোশীক ভাৰতীয় ক্ৰিকেটৰ দলৰ মুখ্য নিৰ্বাচক ৰূপে নিযুক্তি প্ৰদান কৰা হৈছে. So here we have in preposition we have not removed that punctuation mark because it is also important in contextual analysis. Now coming to data extraction techniques. So we have used mainly two techniques. So one is scraping techniques for crowding the data, and also we have used OCR techniques to extract the text data from image or PDF. So for scraping the data from various online sources, we have used the open source framework Scrapy. The X path for each element is coded with a certain degree for generalization in order to replicate multiple web pages. This helped us in crowding a large number of web pages and extracting useful information. To extract image as well as PDF from PDF files, we use Google OCR tools. In domain coverage, we have covered general domains like daily uses, holy books, literature. For the baseline system, we have trained two models, that phrase-based SMT and recurrent neural network-based NMT with attention to estimate the benchmark translation accuracy for English to Assamese as well as Assamese to English translation respectively. We have used this EnAsCorp1.0 dataset, and English monolingual data we have used 3 million sentences from WMT16, which is freely available. So this is the baseline systems result, where we have noticed that NMT obtained higher score than SMT in case of both English to Assamese or Assamese to English translations. Now coming to conclusion and future work, we have presented EnAsCorp1.0 for various tasks of NLP. Mainly it can be used for MT, and it will be available in GitHub link, and we hope that it will greatly help for the research community. Also we have used SMT and NMT system for baseline system, and in future we will increase the parallel corpus as well as monolingual data, and also utilize advanced deep learning architecture to develop the machine translation system for software. We would like to thank Center for Natural Language Processing and Department of Computer Science and Engineering at National Institute of Technology Silchar for providing requested support and infrastructure to execute. This is the references. Thank you.